Okay, the last bit of graphs that we need to look at on the entire course is gradients and areas. And these don't really introduce anything new. All they are different ways of interpreting things that we can already do. Let's look. The first one is gradient. Now, we have done gradient of straight lines in the past. When you have a straight line, we have something like that. We simply draw a little triangle on it. We say that is 12 squares up and 3 squares across, so the gradient is 12 divided by 3 would be 4. But what do we do if it is a curve? Well, we do more or less the same thing. We're still going to draw that triangle, but we're going to have the hypotenuse, the long side, be a tangent. So let's look at an example here. If I'm going to do this with 2, 4, I'm going to use my ruler and I'm going to try and draw a tangent to the curve at that point, which will look something like that. And then once I've drawn that tangent, I'm going to try and fill in the extra bits of the triangle. So what I want to do is to pick 2 points where it's going to be easy to count. So I'm going to use this triangle here. And the reason for that is it's going to be easy to count how far across that is. It's between 1 and 3, so that's 2 squares across. And it's also going to be easy to count up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe 10 and a half. I'll call it 10. What you'd need to do if you want to estimate your gradient is simply do change in y now divided by change in x. So 10 divided by 2 would give me an estimated gradient there of 5. Now you might be able to do this a little bit more accurately than I can. I think from A level I know that the answer to this should actually be 4, but I'm pretty much close enough with my estimated triangle. Okay, let's see if we can do the same thing for minus 4/16. So you try it this time. Unpause when you're ready. In 3, 2. Okay, so there's my tangent. I'll try to draw it as accurately as I can. And I've tried to pick points which are again easy to count. So this is 2 squares across. I think probably 2 squares across is a good general thing for these. And then going up, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 squares going up. Now obviously I'd look at this and think this is a negative gradient because it's going downhill. So minus 15 over 2 would give me an estimated gradient of minus 7.5. Now again, I know from A level it should be minus 8, so that's a pretty good estimate that we've done there. Okay, I'd like you to try the same thing with the part A and part B of question 2 and come back when you think you've got your answers. In 3, 2, 1. So there are the tangent triangles that I drew. And again, for the first one, I can say we want 17 over 2. I can say it's a positive gradient because the graph is definitely tending uphill at that stage. So my estimation would be 8.5. I also know, again, from A level, that it would be, what would it be? It would be about 8. So yeah, that's a pretty good estimate. And then same for 0, 0. I've got 11 divided by 2, but it's going downhill, so I divide that and get to 5.5. Again, I know from A level that should be minus 6, so I forgot my minus sign. So that's another good estimate. Okay, a couple more of these for you to try then. So obviously, if it's a cubic, you do the same sort of thing. We will still want the tangents to the curves. I think particularly interesting in your answer to part B, a tangent can go through a curve once it starts curling back in on itself as well. Okay, do you want to try and draw your triangles for 3? See what you come up with? And I'll show you what I reckon in 3, 2, 1. So my first one is that green triangle. I'd estimate that as being 6 squares down and certainly 2 squares across. And I know it's negative, so I'd reckon minus 6 divided by 2 would be minus 3. And again, I could say that is actually the answer you should get. And then for part B, it's actually a flat line, so you can't really draw a triangle on it. So if it is completely flat, there's no steepness to it, your gradient is just 0. Now, they've got a follow-up question as to what other part of the graph would have that same answer of 0. And it would be at this point here. We call this a turning point. So for part C, it would be at 1, minus 2. Okay. Same thing for question 4, have a go, and come back in 3, 2, 1. Okay, and there's my best goes at some gradients for those. So as far as tangents would go, for the first one, I'd say 10 divided by 2, which was 5, and it is definitely positive because it's going up. And for the second one, it's going down, so minus 22 over 3, which is about minus 7.3. Now, if we compare these answers to the answers in question 1, they should be basically the same. And the reason for that is if we think back to our graph transformations, x squared minus 3 is the same graph as x squared, just shifted down 3. So the gradients at those specific points, the steepness of the line at those specific points, will not have changed, because it's just a translated version of x squared. So there we go, gradients of curves. Just got to get the triangle out and figure it out. So the last thing is area under a curve. Now, this can be done very complicatedly at A level, but at GCSE they're very nice and just say all you have to do is use shapes that you're familiar with. So in particular, we're going to be talking about rectangles, so that's base times height. We're going to be talking about triangles, so that's half base times height. And we're going to be talking a little bit about trapeziums. So just remind yourself that if you've got a trapezium, that's A plus B over 2 times the height. And remember that trapeziums can come this way as well. And you can obviously do the same sort of calculation. So the real key thing is that we're going to draw some shapes and add up their areas. But on a speed time graph, like what we've got here, the area is the same as the distance that's traveled. So that's kind of like the key thing here. There's no real other context where they'll ask you to find the area under a graph, so just get in your head that area is distance, and that'll serve you well. So we're going to use this graph to estimate how far a bike travels in 10 seconds. That's from 0 to 10. That's the area under the entire graph that we can see. So we need to split this up into chunks. Now I would recommend you split it into a couple of bits. I'm going to split it here and here, because those are nice squares that go through what I've got, and maybe here as well. So I will say that I'm starting off with a triangle, that I'm then going to have a trapezium from here to here. Again, you'll have slightly more accurate things than I will, but I'll do the best I can. We'll then have another trapezium, and then we'll have a final trapezium. There we go. So I've got my 4 trapeziums, and obviously if the question says split it into this many chunks, you split it into that many chunks. So my first one is a triangle, so I just need to do half times base times height. So half times base times height. And this sort of calculation is really important to you getting the marks. Okay, it's not enough to simply draw that stuff on and say what it is. You've got to show the calculations you've done. Trapezium, my A is 5 and my B is 7, so it's like one of these sort of sideways trapeziums as far as that goes. So 5 plus 7 over 2 times the height, which is 2, because the height is obviously how wide it is in this case. And that'll give me 12. And then for number 3, it's another trapezium, so this time it'll be 7 plus 8 over 2 times 2, which will give me 15. And then my last bit, have I got enough space? Let's write it up at the top. Another trapezium, this one's going to be 8 plus 9 over 2, but this time times by 4, because it's 4 width from 6 to 10, so that's going to give me 34. So my total amount of distance travelled then would be the sum of those 4 values that I found. So it's 5 plus 12 plus 15 plus 34 gives you 66 meters. Now the question is this an overestimate or an underestimate of the distance traveled? And you've kind of just got to think, are there any bits I didn't count? And if you look at the lines I've drawn, and if you look at the lines you've drawn, you see there's this little sort of shaded bit here that I'm putting in purple, where we haven't actually counted this as part of our areas. We've counted everything below that point, but we haven't counted this. So we've kind of missed some area. So that would mean that our answer must be an underestimate, and that the real answer will be higher than 66. Okay, cool. Let's try one more of these. So, same thing. We're going to use this graph to find how far a car travels. You want to find the area under the graph, split it up into, let's say, 3 shapes, maybe. And then we'll say if we've got an overestimate or an underestimate. Okay, have a go. We'll come back in 3, 2, 1. Okay, that's how I chose to split it up, and the reason I did is that this coordinate here is exactly 3, 7, and that this coordinate here is exactly 7, 4. So my numbers will be nice and easy to do, and if this comes up on a non-calculated paper, that's your primary concern. Once I've done that, I can sort of fill in the measurements that I actually need to think about. So it's going across 4, going across 3, don't need that 3 at the top maybe, and it's going across 2. So what I've got is a rectangle, I've got a trapezium, and I've got a triangle. So let's work out what my area would be. It would be 3 times 7 for the rectangle, which is just 21. For the second one, it would be 4 add 7 over 2 times by 4. So that would be another 22 meters. And for number 3, it would be, it's a triangle, so a half times base times height, which is 4. So my total estimate, based on what I've drawn, would be 47 meters. Now obviously that word estimate is important. You might have split it up into more or less shapes and got yourself somewhere in the 45 to 50 region. I think if you're outside that, then you probably didn't split it up into enough shapes. Is this an overestimate or an underestimate? Well, if we think about it, I've missed out all of this purple area here. So I have definitely done an underestimate. And then there's this extension question, what is the acceleration? Now, acceleration on a speed time graph is gradient. So at 6 seconds, what this question is asking us is what is the gradient of the tangent at this point? So how do we do this? Well, think back a couple minutes. We want to draw a tangent on at that point. So there's my tangent. Now remember, when you're drawing one, your primary concern is to make it easy to count. So I can see that my triangle here goes from 7 to 3, maybe slightly lower. So I'd probably call that maybe 4.2 there. Going across, it goes from like 3.8 to 9, so that's maybe 5.2. I probably could have made my life slightly easier and tried to do it so it went across 5 and up 4, but there we are. If we want to do the acceleration, let's actually put it near the question, shall we? It's change in y, so that's 4.2, over change in x, that's 5.2, and it's definitely going downhill, so it's going to be a negative answer. And that gets me about minus 0.8. Now I think the units for acceleration are meters per second squared, so you can stick that on if you want. But yeah, there's that general idea. If you've got a speed time graph, like we do here, area gives distance, gradient gives acceleration. And that is all for graphs. Nice one. One chapter left.